a few seconds here. All right. Let me share my screen real quick. And I'm going to assume that Zoom is working right now. If anybody can give me a thumbs up that it's working. Yes, thumbs. We have some thumbs. So we're going to get started. Welcome everybody to another edition of Rust and Tell, the second one that we've done online. And we are enjoying this format, despite the reason why we have to do this. It was a lot of fun last time, and we expect it to be a lot of fun today as well. I assume we have people in Berlin and also maybe joining from outside of Berlin. So if you are joining us for the first time at Rust and Tell Berlin, because you're not normally here, then welcome. It's great to have you. And of course, to all of our regular visitors, welcome back. Real quick about ourselves, I'm Ryan Levick. You can't see it behind Ferris because somehow it got moved, but I'm at Ryan_Levick on Twitter, so follow me there. And I tweet about Rust basically only. So if that's what you're into, then maybe you'll like it. And my co-host.
Yeah, and I'm the co-host. I'm a Bastian Gruber, and I'm a software engineer doing Rust for a year now. I'm self-employed, so and yeah, I am always happy to talk about Rust. Maybe approach me on LinkedIn or on other boring social media sites. Yeah, and happy to have you here. Welcome.
So for a little bit, for those who have not joined us before, about what Rust and Tell is all about. This is a meetup, namely about Rust, but really we want anybody from beginner to experts to come and share struggles, ideas, hacks, projects, funny stories, anything and everything related to Rust. No matter how beginner or advanced you are, it doesn't matter. We want to hear from you. Really, we are trying to build a space for a community to learn and grow together. So everybody should feel welcome. If you don't feel welcome, please let us know. And we will try our best to make sure that we improve in the future. And really what that means at the end of the day is that we want you to come speak here at Rust and Tell. And of course, now with us being online for the foreseeable future, it might be even easier than before. We really say we want you because we want each and every one of you to feel comfortable enough to speak here. It doesn't matter how often you use Rust, how long you've been using it for. You might think that you're a total noob. Well, we all are, so that's totally fine. Come tell us about your experiences. We really want to hear from you.
And we follow the Berlin Code of Contact, which might now be the worldwide Code of Contact. What it basically means is we want to have a nice time here. There's no reason to be or to get harassed, to complain about unsafe code or noob code or whatever you think it is. This is just a space to have fun, to exchange. We all use our free time here to do the best, to hang out and chat, and to be a better version of us after this group meeting. So if you don't feel like you fit in here because it's not advanced enough, maybe don't be here. And if you feel like you're getting harassed or something, please contact us. We take this very seriously. So anything you don't like about this meetup, please approach us and we will deal with it.
All right, we wanted to give a special shout out to Jan Erik, who is helping us out tonight with the Zoom and with the Matrix, as he usually has been. So thank you very much. It's always appreciated. And we have, oh, it seems we have somebody speaking. We have 3 talks tonight that we will be going through. This reminds me as well, we are recording these talks, and so it might happen if you're in the Zoom tonight, if you put on your camera, that you might be recorded. So if you don't want that, make sure to not turn on your camera, or you can watch from YouTube or whatever you want to do, just so everybody is aware. So the three talks tonight that we have, the first one will be from Tim, who will be talking about writing a clipboard manager in Rust. Then we have Chris talking about a matrix server. And then Mahmut will be back again talking about cluster management distributed data protocol called Artillery, written in Rust. So we should have a good night. And if you have any questions, feel free to write us in chat and we will make sure to help you out. So thank you, everyone. And let's get started with the first talk then.
Okay, so let me share my screen now. Okay, can you see it? Okay, okay, so hello everyone. First, I'd like to thank you for making this this event online, and I really think we need more of it in future. So thanks. Okay, now to the talk. My today's talk is Dev Diary, writing Clipboard Manager in Rust. And here's the agenda. So first I talk about goals for a Clipboard Manager. Then I'll go with process of picking a GUI crate for Rust. And then I'll describe a few encountered issues. And lastly, a few random slides. Okay, so my app goals for a Clipboard Manager was that it runs in background. It saves history, of course, and you can pick an item from the history. So very basic feature set, actually minimal what you expect from the Clipboard Manager. Okay, so this is my first time when I wrote Rust GUI program. So I am totally noob, and I started by looking into RE-GUI page, and I found that you can write Rust code. You can have three approaches to that. One is native approach, one is the second one could be cross-platform toolkits, and the last one is Rust-centric approach. I'll briefly describe all of them. So I picked the Rust-centric approach because because I could. Mainly what is all about? In Rust-centric approach, you write Rust code, but the outcome application looks a bit different than the rest of the platform. The rest of the platform. But I'm okay with it since this is a simple Clipboard Manager, no client involved and things like that, so that's okay. At the opposite end, there is a native approach where you write separate code for each platform. So for example, in Mac, you would write Cocoa, and for Windows, it would be Microsoft Win API. And then you call that from through IPC or FFI. And somewhere in the middle is the cross-platform approach, where you don't have to write separate code for each platform, since you use cross-platform toolkit, of course. But you still have to call FFI or IPC from Rust to those toolkits. Okay, so once I picked the approach, I had to pick GUI crates for Rust, and I found these ones. And after a brief review of all of them, I found that I'd like to work only with Druid or Iced, mostly because of the activity in those projects. So I checked GitHub activity, which looks like this for Conrad and rest of the project. note that these graphs came from beginning of the March, so it may change so far. And this is how ICE looks, and Druid. So Druid and ICE looks the best in terms of activity, project activity. So at this stage, I played around with Druid and ICE API. Both API looks very convenient, and I had a really good time working with them. They are also quite similar. But I finally decided to use Druid because it seems to me more like a team project instead of one-man project like ICE. Okay, so no matter what I told you so far, I recommend you to do your own evaluation in case you want to write GUI program, because I'm a bit biased. So my choice was Druid, but your may not be. Okay, so let's talk about encountered issues. Shortly after I picked Druid, it turns out that it doesn't support taskbar application, which is usually what you do when you write Clipboard Manager. But it's not a big deal because I thought that I could make it my own in the program, because typical taskbar program consists of runs in background. It allows you to register a hotkey, and it supports tray icon. So I don't care about tray icon. And for hotkey registration, there are also crates, so this should be easy. Okay, so my concept for the program would be something like this. First, you register a hotkey registration which is responsible for GUI, for showing GUI, and in the loop you record clipboard content. Okay, so let's start developing, and we've got roadblock number 2. So yeah, it turned out that App Launcher, which is a thing of Druid, couldn't be run twice or more. And this is actually, you run it when you initialize your window, so it's quite often. Yeah, so it's kind of problem. But let's see what else we have. Then it quickly turns out that one of the hotkey registration crate doesn't support key combinations, and also it doesn't support Wayland, which was my assumption at the beginning. Okay, but it's not a problem again, since there is another crate, input bot, and hopefully it works pretty well. I mean, it solves problems of the previous, but it requires sudo to execution. Actually, Wayland requires sudo to execute that, but yeah. Okay, but it's not a problem. We can live with sudo, and probably maybe fix that later. What else I found? Yeah, this one was a bit tough, because it turns out that X11 clears the clipboard when the program is closed. I mean, let's say you have, I don't know, Firefox window. You select a text there, you copy that to clipboard, and then you close the Firefox window. The clipboard item is cleared, and yeah, so this is another problem, and it occurs when you allow user to select an item from the history. Okay. Unfortunately, this wasn't the last problem. I also found that Druid can't be programmatically quit. You can't programmatically quit from the Druid application because of this bug. And at the end, I found that there is some kind of inconvenience when you try to use it in GNOME environment because the window, because GNOME prevents you from pop-upping windows. But it's minor. You can work around it with, I don't know, Still My Focus, for example, extension. Okay, so at this stage, I started to get a depression a little because I thought that would be a weekend project, for example, and everything around me told me that I would have to fix ecosystem around Clipboard Manager. Yeah, so that could be fun also, but my initial plan was a bit different. So and before I started to fix the crates, ecosystem, I found that maybe I could change the concept, my initial concept. So instead of putting everything into a single process like before, I thought that maybe I could split it into two processes. One process would be responsible for recording clipboard content, and the second process would be responsible for showing GUI. And how does it work? Yeah, it works pretty well because we don't need all mentioned. We're skipping all encountered problems. So this is great. For example, why don't we need, for example, hotkey registration? We can delegate that to GNOME, for example, which has built-in registration, hotkey registration. So why not use that? Okay, so quick recap. So I was able to deliver MVP. I published the code on my GitLab and learned a lot. For example, that it's always good to reuse existing software, like set GNOME hotkey mechanism registration. I learned a lot about X11 and Wayland, about their differences and how X11 is insecure, and how Wayland fixes that. Okay. Also, I was told that I shouldn't write Clipboard Manager in the user space as I did, especially for Wayland, but not exactly. You can write a Clipboard Manager, but maybe you should consider using data control protocol. And also I learned a lot about, maybe not a lot, but some stuff about encryption using Ring, benchmarking, but unfortunately I had to remove that from the slides. Yeah, and I found that Rust trait, error trait got way better than it was before when I use it. In the meantime, at least 2 of the mentioned issues got resolved, so it's great news. And I think that's it. So do we have time for questions maybe?
We have time. So far, I didn't see any questions yet. Feel free to write them now in the Zoom chat or in the Matrix chat so we can pick them up.
Okay, so I'm stopping share my screen right now.
Anyone, any questions? No. Seems, no, someone is texting, so we wait a bit. Bram is typing, I see.
And since we don't normally have the opportunity online to give our speakers a round of applause, on behalf of all listening out there, thank you very much for the talk. It was really great.
There was a question now from Uwe, and he asks, what do you think about GTK RS?
So I haven't worked with GTK RS, but I know that if I'm correct, then Druid RS uses underlying the GTK RS. So yeah, that would be my guess. So yeah, I think it works. I don't have much knowledge about that because yeah, but I think that Druid use it.
Cool, thank you. And we have two more questions. One person asks about screenshots, and the other, Bram, asks about if you have specific features in mind for the future.
Yeah, so I've on my GitLab in the Clipboard project there is a to-do list. So I'm not sure. Clipboard managers are pretty well, I don't know, explored thing because there is plenty of them on the market. So I don't know. I'm not sure. I'm open to any features. So MVP works. I use it, and about screenshots, right? I could find. Actually, I'm using on my computer this Clipboard manager right now, so I could even show it. Yeah, but of course I can. I will send screenshot on the matrix. Is it possible? Because I haven't done it yet.
It's possible.
Okay, so I'll send it.
Cool. Thank you. And I think this was all of the questions.
Cool.
Tons of
Thank
claps
you.
And good talk.
Thank you.
Yeah. Thank you for talking and sharing your project. It was fun. Okay. Are we ready for the next speaker?
Yep.
Hey, Chris is next. Cool. Take over.
Hey, everybody. Great to be here, finally. Today, I'm going to talk about a project that I started called Maelstrom. So let me share my screen real quick. All right. Hopefully, you can see this. All right. So Maelstrom. Maelstrom is a high-performance matrix home server written in Rust. It's really designed to be storage agnostic, scalable, and light on resources. You may ask, what is Matrix? We have it going today here, which is cool. But Matrix actually is a messaging platform. It's decentralized. So right now it uses Federation to share messages between what they call home servers. They are doing a lot of work on P2P. So you actually can run a home server in WebAssembly and be a complete node to yourself. And so there is no even federated server that you need to connect to. In that case, you would connect to other P2P peers and exchange messages. It just enabled end-to-end encryption. One of the coolest things that really attracted me to Matrix was bridging. It has a lot of support for, and I think maybe this is what it was originally designed for, was to take a lot of different disparate networks of messaging platforms and combine them all into one. So there's bridges for WeChat, there's bridges for Discord, Slack, you name it. And so it's a pretty interesting concept. And then when you really start to look at some of the P2P features down the road, it really amounts to something pretty neat. Also, it's open. So I don't know about you, but I have SMS, I have iMessage, I have Discord, I have Slack, multiple Slacks, I have email. I have so many streams of messages coming in. And most of those platforms are all closed. And it really sucks that I have people on WhatsApp, which I hate WhatsApp. And I want to get them over to Signal, but it's like a platform switch for everybody. And so I'm really hoping that the future, maybe something like Matrix, where It is open standard. It is not centralized, and the open protocol enables a bunch of bridging to work. And so I think this is one of the things, if you think about the internet, the email is very federated, which is, it's a pretty good system, but you see the centralization of it. And so a lot of the things about Matrix is really this kind of Web 3.0, if you will, which is more of a peer-to-peer decentralized web. And so I really think that we need to get back to that. I think a lot of companies, as you know, sort of is a bad steward of our private data. And I think most of their business models are really vested on locking you in to their platform. So if you look at Matrix stats, this is a bit of an old slide that I picked up somewhere, but right now they have about 14.7 million global accounts. They do 5 million messages a day. They have 4.3 million chat rooms. There's 40,000 federated servers, which is, yeah, kind of mind-blowing. They do about 3.5 thousand messages out per second. And 500 projects are developing with Matrix now. There's 100 companies using it, and there's 4 countries using it. In fact, I think maybe France or somebody just, or maybe Netherlands, I forget, but one of those just also settled on using Matrix as their core messaging platform. So if we look at the landscape, there are quite a few home servers. And so in the Matrix land, the home server is essentially kind of where your account home is. And you create an account there, and then it federates that. So if somebody, if I'm on one home server called matrix.org and you're on a home server called, rustandtell.org, and we want to exchange messages or share a same chat, be in the same chat room, all those messages are destined for that chat room, and to me, would live on my home server. And so the data is federated between the two. The current sort of reference implementation is what's called Synapse home server. It's written in Python. It uses Postgres. They also have SQLite. It's built on the Twisted framework. And lately, I think they've had a lot of scaling issues, especially with the COVID stuff going on. They've seen just a huge increase in usage. And when you're on a Matrix home server, you could actually feel the slowness. The Python as a reference implementation has been built from day one. So it's a pretty large code base, and it's evolved over time. So I think, as a developer, you always know you build it once. The first time it's kind of hacked together, but you always know that you can do it so much better if you build it a second time. And so that's what they started to do. They started to build a more scalable server called Dendrite, which is, I think you're also seeing a theme here with Dendrite, Synapse, those types of things. But Dendrite is a Go server, or it's written in Go. It uses Postgres and SQL. It's a very heavy microservices architecture. In fact, all the major services, like a chat room, like room management, user management, they're all separate Postgres databases altogether. And so, it's been kind of designed from the ground up as a very sort of microservices architecture. It's a bit complex. It's still under heavy development. It's not ready for any kind of use yet. And they've actually been using it a lot more for the playground aspect of hacking on things. So a lot of the end-to-end stuff kind of hacked on there. The P2P stuff actually was built with Dendrite. And in fact, what they did is they compiled it to WebAssembly. And so you basically run your own home server in a browser, and you're able to have a fully end-to-end P2P connected home server, which is really neat. And that's, I think the future is P2P. So I think there's a lot of cool stuff that can be actually evolved from that. There is, in fact, there's 2 different Rust servers out there in the market. So there is one that's been around for quite some time called Ruma. It's been around since, I want to say, 2015. I'm not 100% sure, but it's kind of been abandoned. It's built on Iron. It's not asynchronous, obviously, a relatively new feature. It's just dated a little bit. And they also built a lot of heavy modules that sort of abstract a lot of stuff away. So they have this whole complex kind of micro or macro language to build API endpoints and things like that. Which is probably good in some case, but it's also a little bit hard to, in my opinion, sort of reason about what's going on there. And so somebody recently started a conduit home server. It's written in Rust. It's using Sled, which is pretty neat. It's built on Rocket, the async branch. Again, it's brand new. It's a couple weeks old. It's a very hackerish approach. So it's very about kind of just making things work. Not a whole lot of structure yet. It's evolving. It's pretty cool to see. It's kind of a one guy show that's gotten a lot of traction recently. But again, I think just a heavy use of the existing Ruma modules is kind of what this whole thing's built on. So there's a little bit of legacy there, maybe not a whole lot, but a little bit. And so Maelstrom. So obviously building my own Rust server in a home server in Rust, and I just started this project a couple weeks ago. It's written in Rust. I'm trying to be storage agnostic, so we actually have a storage trait. I want to be able to plug in anything, Postgres, SQLite, Sled. A lot of the storage trait, we really are thinking about, you know, you don't necessarily need a microservice. If you really wanted to abstract away certain services into different storage structures, like maybe Kafka or something like that, you could just create a new storage trait is our thinking. Again, we're right at the beginning of this, so a lot of architectures has kind of been thought about, but you know, I think a lot of stuff will uncover as we go. It's built around Actix Web. You know, I'm glad the project came back from what looked like certain death. It is still fast, super fast. And when I did some benchmarking against Rocket and Warp, it's still like 2 to 3 times faster. And I know it's, you know, benchmarks, this is probably not going to be the, you know, the hot path in this thing, but I think as you'll see, everything that we're trying to do is really performance focused. Again, this project is just a couple weeks old. You know, it's a lot of emphasis on code architecture and just a good structure around how we're laying this code out, and a lot of heavy performance consideration. So you'll see that our project goals are really about fast and scalable solution for a large user base. What I'd really like to see is I'd like to see Rust replace some of these you know, performance critical areas. And so I've used Rust servers for a lot of things, you know, in sort of a performance critical area. And I'm just blown away by how scalable it can be without any effort and how minimal of resources it uses. You know, so things like doing, you know, 6,000 requests a second on a $15 DigitalOcean box, and it only uses, you know, maybe 10 megs of RAM. It just blows my mind. You know, me personally, I've done backend development for a long time, and so I think it's really super cool that with little effort, you can build some very highly scalable, you know, low overhead systems. So the project goals obviously are fast. I think it's a big thing. Storage agnostic. Again, I think we should be able to plug in SQLite, Sled. So one of the other contributors is they have a self-hosted server. Basically, it's a box that you plug in and encrypts everything. It runs like blockchain if you want. And so their goal is to run this on kind of a Raspberry Pi equivalent hardware. So really looking at, you know, Sled or SQLite on an embedded platform, or Postgres or other things when you want to scale this up on, say, a Kubernetes cluster. Efficient. Again, I think, you know, we get, when you develop for cloud, you got to get into this mindset that, you know, you don't have to be that efficient, but those costs add up. And so it may be a bit of a hindrance, but, you know, everything that we're really focused on is efficiency. So you'll see a lot in code that we use cow, copy on write semantics. We do a lot of, you know, borrows when we pass things around. So, you know, for me, I haven't done a whole lot of high performance Rust. It's a great project because, you know, 1 or 2 other folks that are working on it are very performance minded. They've done a lot of stuff. So I'm learning a lot. And I think this is one of the things that attracted me is really, what does high performance Rust look like on a backend service? So it's pretty cool. Again, clean, non-legacy code architecture is really what we're looking for. So trying to not just take what's out there and implement it, but try and, you know, really look at making this something that's easy to maintain and hopefully welcome new users. And then, you know, call me crazy, but I've done a lot with IoT in the past, and I think that there's something here. So Matrix had this concept of kind of being something for Matrix or for IoT. You see IoT littered in some of the documentation. It really hasn't panned out, but But when you start to look at kind of this P2P aspect of it, I think there is some benefit there to the way that the message passing works and the way that they build a DAG to sort of to merge different messages on different home servers. So it's partially an interest here. I don't know if it'll ever pan out, but kind of one of the things I'm thinking towards is, you know, something that may be a good MQ, like a distributed P2P MQTT type replacement. So let's just have a quick look at the code. I'm going to, let me share my screen here with code. And I'll just give you a quick just overview of the project. I won't go too deep, but I think, you know, I think you can see that, you know, what we're really starting out to do here. I hope everybody can see this. So again, this is obviously on GitHub. I'll just give you a high level thing. So this storage structure here is under DB module. So I don't know if, I don't see a lot of Rust projects use heavy modules, but you know, coming back from the Ruby on Rails days, I'm a big fan of sort of that model view controller, you know, philosophy. So, you know, call me old fashioned, but this is kind of how I started to model it. So you have the server concept, the server has handlers. The idea is that these handlers, which are the things that actually respond to the web requests, come in. And from there, you might, you would basically just call models, if you will, and render the output. Models here are just, you know, again, this is a new project, so we're still pretty early, but models here are, you know, obviously represent sort of the data structures in here in the system. There's a lot of data structures. There's a lot of endpoints. That, you know, the REST interface for Matrix server is huge, so there's a lot of work to do. And the DB, what I think is kind of cool is just the storage trait that we've done. You know, we basically created a very simple store. You know, we basically wrap PGS or SQLX for the Postgres. You can pretty much do anything with a storage trait. What's nice is the storage trait, because we have these, you know, these sort of simple things like, you know, get a device, set a device, things like that. The mock thing makes it really easy, because I don't know if you've ever had to write unit tests, but whenever the database involved, it really kind of stinks because you're bringing up a database server to test. And so this mock object really makes it neat, where we actually just create, you know, create a structure, and then right before your unit test, you just set the value that you want returned from your, you know, your expected return value from the handler. And it makes it really nice to be able to mock this out. And so from the get-go, since we're doing the storage trait, it makes it pretty easy. What else can I say here? Yeah, not too much here yet. So again, you know, I think we focused a lot on structure. If you look at sort of the main module, it's pretty simple, just inits the config, you know, basically starts the server, and that's it. And so, you know, we've done a lot to try and keep this clean and modular. All right, so let me go back. All right, so let's see. So yeah, help. I mean, part of my whole thing is I think is a great time if you ever want to get an open source project and you want to get into, you know, API or server side development. It's a great project. It has a great spec already written. They have complete open API docs. It's a well documented spec, so it's pretty easy to implement. Trying to be as beginner friendly. So we have a Matrix channel. I spent a lot of time just helping people try and get through their first commit. There's a ton of work. Again, there's a lot of endpoints. So there's lots of things to take off. I think I copied all the endpoints over to issues in GitHub, and it's like 100 endpoints. So lots of easy things to pick off, and it's brand new. So I think it's kind of cool to be, you know, it's hard to come into a project that has been established and make a, you know, meaningful dent. You know, the barrier is a little bit higher, but I think with a brand new project, it's great because so much stuff to do. You get to be involved in the architecture. So I'm hoping that some of you will be interested in checking this out. And you can check it out. It's at GitHub, Maelstrom, IRS, Maelstrom. And then you can reach me here. My company's hiring. If you're in Germany and you want a Rust job, feel free to reach out to me. is my email and Twitter handle. Questions?
Thank you so much, Chris. This was an amazing talk.
All right, I will stop.
We have a few questions, yes. If I scroll up, someone was asking database agnostic instead of progress, which grades might it be? Or I think the person might ask, how are you accomplishing a data agnostic stack?
Yeah, so we basically use a storage trait. So we create a trait that has sort of the high level functions, if you will, about what needs to be stored. So for instance, if I want to get an account, there would be like get an account, that you need to implement. And the models that return from the storage trait or that are sent to the storage trait are there. And so because we define all of the sort of, the interface between what the storage layer needs to get and set and the rest of the application, it becomes pretty simple. And then what we do is in the beginning, we look at the connection string and then we initialize the correct storage. So in your initialization function, whatever struct or whatever structure you create for this. So for instance, we use SQLX, which is pretty cool up and coming project. And we basically create a structure that has a database pool in it already configured. And we implement the data storage interfaces.
Okay, cool. We have a few more questions. I will grab them first from the Riot chat. So someone asked for the project URL. Maybe you can post it afterwards again in Matrix or in the Zoom chat. And then the next question is Matrix protocol all REST, or is there some WebSocket front end?
Nope, all REST. Surprisingly very simple. And for some of the P2P stuff, they're looking at doing it over co-op, which would be something new. Very lightweight REST, but it's all REST. The hard part really is in the version control, if you will. So most of the systems use a directed cyclical graph to sort of use very much like Git, but all these home servers are keeping track of their local copy of a chat room. And so that's all merged. So that is really the hard part. They do quite well. They do a long poll process. So it's still a GET request. It's not WebSocket. And, it's pretty responsive. It looks good. So it's very simple. That's the beauty of the REST interface. It's super simple. And this is why I think it's a good project for anybody that wants to get involved in something. It's not complex. It's pretty simple and straightforward.
Okay. Thank you. Maybe three more questions, quick questions. Do you know why Conduit went with SLED? And I might have missed it, but do you use stuff from Rumor?
So, okay, so the first question, so Conduit went with SLED because I think they kind of want a batteries included sort of turnkey thing that somebody can just launch their own home server. And again, the guy that does it is super cool. Him and I, chat a lot, and, he's just looking for kind of a hack together system. He relies heavily on Ruma, which I think is good. It's been a lot of work evolving those libraries. And we're more of a, we're trying to appeal to both sort of a large scale implementation as well as an embedded solution. So again, I think we want to be agnostic. SLED looks super cool, but it's not 1.0 yet. And, I think we'll implement a storage trait for SLED kind of when we get a little bit more solidified on the data structure. Now, in terms of Ruma, yeah, we are trying to use a limited part of the Ruma. So Ruma, and we've been working with the maintainer of Ruma, which is this guy, Jonas, super cool guy that's doing a lot of work to maintain that and trying to give it back. And so because we're performance minded, we've been trying to push back some sort of things like, using cow or copy on write structure for some of those things. I'm trying to stay away from some of the macro stuff. The macro stuff is really neat. It'll save you a lot of code when you're implementing API endpoints, but it's also kind of it's black magic in a way. The way it's structured, it's kind of a lot of stuff is hidden from you. And not that that's a bad thing, but what we're trying to do is make our, even our API layer or the server side to be able to easily be replaced if we want. And so, we're just trying to make it more accessible.
Okay, amazing. This was really, really interesting. There are a few more questions in Zoom, but I think, yeah, there are 3 more. Maybe you have time to answer them in Zoom. Like there's somebody asking about no STD and no alloc for embedded. Maybe you can give a quick answer there, and then you can answer if you want to the rest in Zoom.
Okay, great. Well, thanks everybody. Appreciate letting me speak here, and for those that listen, thanks.
Okay, people, we have a little break now, and we have the tradition that we break out in breakout rooms. So we will have 6 rooms with 10 people each. So you will get assigned to a random room. In case you want to talk and chat with people, feel free to activate your phone or your camera. If not, just don't join the room or leave the room. Don't talk. Feel free. But I think Jan Eric is gonna create the rooms now and will assign you to a random one. We have around 5-10 minutes, and then we will be back with our third and last talk. So thanks for attending so far. Thanks, Jan. Okay, people, we are back. Thank you for sticking around. Based on the amount of participants, we are all back. Maybe we lost 2 people. That's a good ratio. I think we are ready, right, Ryan?
I think so, yes.
Cool. Someone said the breakout rooms were too short. That's a good sign. I guess we can try the next time to make them a bit longer. Also, to feel free to exchange Zoom credentials. I think you don't even need to. Hang out afterwards in Zoom rooms, and we try to make them a bit longer the next time. Thanks for the feedback. And here we go. We have our last speaker with Mahmut. And he presented already, I think, twice at the Rust Berlin, but never on Zoom. So here's his first time. Give it up for Mahmut and take over.
Thanks, Bastian. And let me share my screen. So I hope you see it. I don't know. Right now, okay, thanks, cool. Today I'm going to talk about artillery. First, everyone should be okay, and everyone, I hope, feeling good and safe and healthy at home. And today I'm going to present artillery. It's like this fancy name is just a description of the repository, but it's basically for the things that I need at work, and also things that I need to use for for the storage systems, distributed storage systems. So who I am, I'm Vertex Click on internet. I'm doing data processing engineering by day. I'm academically working on the experimental software. I am currently lead of the localization team in Rust, and I'm member of the community team by that. And this is my website. And let's start. So distributed systems, yes, this is the topic of today. And so everybody talks about distributed systems. This is very important. Everybody gives some ideas about it. And everybody has some knowledge about it. But is it easy? So making distributed systems are not semi-hard. From my point of view, it is hard. So this is, by definition, it is like that. Everybody talks about it. So what I can say is that we are going to go through from ground up how can we do the service discovery, how can we form the clusters after that, and then do the distributed data replication. I wrote data replication, but it's basically distributed data replication. So from zero to hero, all things is inside the artillery right now. And I would say everything is basically compartmentalized. And I think in the Rust environment, everything should be compartmentalized, component-based, and neat. And this is how we are going to do this, and how artillery is architected. So this is the first need I need to give, and diving into the service discovery. So let's talk about this a little bit. How can we share the configuration? When we talk about the configuration of instances, how do we share? How do we discover the network topology? And most of the times, what we do is that we have a central shared state store. We build up some kind of a central shared state store. You call it console, you call it something else, you call it etcd. And you basically deploy this with all of the services together in the same network. And you actually register these instances or the service descriptions to this key value store. This central service shares the configuration or network topology in the local link at the same local network. And we write a web API with hash table lookup. So it is basically it, right? All these centralized services, like, I mean, in the previous slide, I think Chris said that the future is decentralized. I totally agree. This is correct. What we are doing in most of the times in the production workload is basically deploying some kind of a small service that is actually doing some kind of a configuration distribution. This is wrong. Again, in my opinion, I always give subjective opinions in my talks. This is my opinion. And it feels like every single time when somebody deploys something like this, it feels like they just deployed a hash table. And then I'm thinking that bringing the ancient tech back into the foreground is the good thing. So all of the distributed system engineers best at that. So they change a little bit, put some mesh up, and they serve into your face. So this is how it is going to work. So ZeroConf is the thing. And 20 years old stuff, yes. Nearly 20 years, maybe more than that, yeah. Network is unreliable. Planet scale systems are not for the network. They're based on rendezvous. So, I think rendezvous is a good thing on the local network. Configurationless networks are the good thing also. And service discovery should be conformed to rendezvous style, the rendezvous mentality. That form is the good form, I would say. So how ZeroConf works, there is something called bonkers protocol. Let's say there's the instance is serving at 1337. And there's also crazy protocol that some other server serves. Also, in addition to the bonkers protocol, they are actually in the local area network, they're saying that, yeah, I mean, I'm serving this, I'm serving these services and stuff like that. I mean, this is my IP, you already know it from the destination, yeah, and source and stuff. So let's, if it's okay with that, and if your software is aligning with this, let's talk on that protocol. This can be from broadcast from one server to all the servers, or in the UDP style, any cast, so one server to one server directed, or hop-based. This can work quite good without any configuration server that is running around. So where this thing is used from high performance computing to the wireless sensor networks. We are not using that much in the cloud. Why? Because we are using something called Kubernetes, and the star, I put asterisks in there because core DNS, kube DNS, service meshes and stuff like that, handling these kind of things. True, I mean, you might not need that, but let me tell you again, DNS also kind of centralized, even nobody wants to admit that. But this is the thing. But if you say still want full-blown zero-conf, then use Kubernetes with the host network. This is just a one single line, just host network through, deploy this. In the Amazon, in AWS, there is something called the CNI driver. So you can deploy the CNI driver to the, with the, configuring the CNI, you can deploy that zero-conf network inside EKS and stuff like that. I mean, you can use host network to send broadcast messages. This host network is basically that for that. And you can share network topology without intermediate third-party server or funky demonized web applications. Yeah, like I've said before, I call it funky demonized web applications. I don't think that this is needed, and it shouldn't be needed at all. So at this point, when we come to that point, and when we know how this thing works and how the configuration is distributed, we can say that we established a network at the linked local level. So in one single data center, in the ones in an n amount of nodes is already in the already established kind of a mesh, they call it nowadays. So this is the good part of it. We know that this is one single data center. If you want to go cross data center, so data center to data center discovery, if you don't care about the broadcasts, and or if you want to do some kind of a optimization to the lookups, you can use DHT. So this is one of the papers, one of the most prominent papers about the using DHT in the packet bodies to discover the other data centers and their topology. And this is actually a good thing because DHT at the server level, I mean data center level or the cloud level, it's nice. It's not privacy delving, I would say. Either zero-conf or another way, you will find discovering the services, I think. And I started with zero-conf. It was the easiest for me. And Artillery comes with built-in zero-conf with both pure broadcast, like I said, and UDP anycast-based methods. This is actually makes everything get tested and also kind of helping me to find out the IPs in the commodity hardware deployments and stuff like that. So at that point, we have the IP information, I would say, and I need to form a cluster. So I need to form something that makes nodes communicate. So the upper level protocol, going to the application level, kind of a necessity. So forming clusters. I need I have some requirements in my mind when I'm doing this. And it should be very flexible that every single user also who wants to develop some kind of the query engine or database system should also use this. And or some kind of like peer-to-peer application or whatever you want to call it. That is also a good thing that can be used, I think. Forming a cluster and receiving membership events is needed to make the communication medium for nodes. So members can go down, members can join, members can actually talk about these kind of things like their state. And this is how we need to communicate about. These are the things that we need to communicate about. Also, it is needed for the database systems to look up for replicas or their status, not for the replicas or their status, continuously, like kind of heartbeat messages between the instances and stuff like that is nice. Or any other service, actually, not only data services or data systems, to be honest. So the protocol should be flexible. So I mean, in the paper, it says that there are 4 states, and the replicated state machine has 4 states to actually distribute the work. But it is not like that. On reality, everything in the academy is like with pink glasses, everything is beautiful. But when in reality, it's not like that. So you need to alter the existing paper implementation to conform to the actual use cases. So probably one of the users on common say that they want to send some kind of custom packages, custom messages. This will allow that, and it allowed that. This was the requirement. And the network shouldn't be congested with packets. This is the other thing. Broadcast storm prevention, congestion, and all other things should be considered during the design. And I need less packets and more work. So this is related to congestion, bounded uppercase traffic. So it should actually slow itself down at some point. So I'm thinking about what can be the algorithm. So what can be the protocol, what can be the algorithm, how I can implement this. I said epidemic. So it's very well known, everybody knows it. Actually gossip, let's call it gossip, because rumor mongering protocol, you can say. This is a thing that actually helps you to form the cluster and get notified by the membership changes and events and stuff like that. So I implemented this even like fully custom message delivery based membership. And I also implemented the user-defined events that you can send any payload up to the your router's fragmentation scheme or that orchestration system's virtual networking scheme allows you. You can serialize anything to Bean code. I mean, anything from Bean code to the JSON or whatever, and you can serialize to anything and just send it because it's just bytes. So maybe you know that I am also working on with a bunch of cool people on Bastion, and you can back it up with Bastion. So you can just put inside the Bastion, and you have undying, fully reliable AP available and partition tolerant distributed cluster with custom message send events. So and you don't need to call someone when it fails because you wrote the code. That is it, and it's not going to crash down. That is the good part of it. When I write it, I was thinking that I should make it well tested because I want to use it in actual workload. And I need to do more checking with model checkers and the possible worst case scenarios. And one of the best things that I'm looking for is that Monte Carlo related methods and stuff like that, that will check the distributed system model. And currently I'm working on that. I check the worst case scenarios, not best case scenarios. I mean, this is where the stochastic methods are shining. And meanwhile, I released the chaos testing harness called Chaos. It's like in my language, it's called Chaos. And I was like, somebody took the Chaos crate. So I think that was the reason that I put this in my language. So this enabled artillery to be tested. So it just randomly flanks in the points. But you define the flank points, and these are the very important flank points that might actually crash the system. This thing is also open sourced. Meanwhile, I worked on that, and then publish this crate. So in reality, how it works is like this. So this is just for node local AP cluster, and don't mind the IPs because I didn't enable the discovery part because I mean, yeah, broadcasting is not working on some stacks, to be honest. That was one of the reasons, I think, especially on the link in the local level. Yeah, I mean, and then I overcome with Anycast method. So this was from one of the old videos. So this is, as you can see, there are membership events are sent to each other, and then sometimes random increment of the membership states are pushed down. And forming the clusters is like that. It was like that. Artillery comes with the mentioned membership protocol, and in the future, for distributed actors, we can use just this, gossip to exchange messages. And one of our members in the Bastion, actually, I just learned that he wrote some kind of the in Erlang community or in the Erlang language, something called a term to binary serialization. So I mean, if he wrote this Erlang serialization crate, so if we can make this happen, so you can communicate with the Erlang clusters from Rust with their own protocol scheme, I think, and we can put it in the artillery also. That is one of the good things I would say. So next up was the data replication. I just passed, but this is the part that is actually got funky, and I implemented this in 2 weeks. And yet another one, the fresh protocol is coming up for data replication too. I'm just going to present 2 protocols at the same time in here that is going to do data replication. So we formed the cluster. So right now everybody knows everyone in this local linked local network. Now we come to the point that we need to share data, well, like huge data or objects, big blob objects, big object blobs. And we need to work on these work on these things, read and write. So we start, again, some requirements. Now nodes are aware of each other. They are doing rumor mongering. Network is in place, topology is in place, like I've told you before. Need to replicate data between the nodes. Let's have a strong consistency, please, because people are tend to do the strong consistency, and they are using wrong algorithms to do the strong consistency for the data replication. That is yet another topic I'm going to come that on. And don't use consensus that doesn't mean meant for data replication, but just for agreement. That is also yet another thing. Our fault tolerance strategy should be one or all style. Maybe one downside is that against the other consensus-based approaches, but this actually amortizes that what it gives to you, I think. The protocol I'm going to mention soon. Lightweight replicated state machines. The protocol should have lightweight replicated state machines. Logs should be ordered. This was the what I wanted to have. To need to old style order probably. And yeah. So everybody's going to say, yeah, I mean, yeah, Raft, yeah, but it's not for data replication. You say Paxos, yeah, but it's not for data replication. No, it's not for that. It's just for consensus. Like you want to have a agreement on a value. It's not for replicating a value. It's you are just replicating with a third channel. You are just doing something else over it. So it's not actually, both of them not actually meant for actual data replication. And when I think about what is the workload that probably I'm going to get at work, is that, and I researched a little bit more, and most of the workloads are mixed workloads. It's 60% read, 25% update, 10% insert, and 5% scan. This is from the Yahoo's benchmark, and it's mixed workload definition for Cassandra and Cassandra-like. This was what was the mixed workloads are. And then I am reading a bunch of papers in this between these two slides, and I'm just like reading this, that you're seeing this graph saying that the update operations are not actually, even for the 10 times more update operation, throughput doesn't change that much, in a sense that was actually expected and the percentage level. So I'm like, okay, so most of the workloads are read only. Read mostly, sorry, and it's hard to make, seems like, the read mostly workloads available with low latency in these circumstances, especially in the like Tenenbaum says, in geometrical geological distribution. This is what I discovered, and then I'm like, oh yeah, chain replication. Best thing ever. And yeah, it's like probably in there for a long time. Oh God, I mean, it's like somebody is going to probably implemented this. No? Yeah, no. I'm just looking how chain replication works again. And it's basically what you see in here in the left-hand side is the normal, ordinary chain replication. Query is run with a tail, and the updates are hit from the head of this linked list of a node chain. And advanced mode, apportioned queries mode, so the crack mode. Yeah, I mean, I'm not supporting anything. Its name is crack. It says that AQ part is apportioned query, so all the read requests are distributed over all the nodes with the strong consistency guarantees. There's also eventual consistency, maximum version bounded eventual consistency, and stuff like that for the log consistency, version consistency related stuff, but strong consistency can be enabled by that. So I'm implementing this. In 2 weeks, I've implemented that, done, and that has a very good read throughput in the single threaded synchronous workload. Right now, log free, except the one that I need to remove that I actually forgot, CR implementation. So it is actually doing what it's supposed to do. And it has Rust's safety, concurrency, and speed is the best combo that I realized one more time again, because it was neat implementation. And I just wrote the wire format and then just slam the things that I need to do. Yeah, okay, log free was not fancy at all sometimes, but yeah. Tested, but not on the cloud deployment yet. I will do it. And what needs to be done is garbage collection for the replicated log. Realize that I actually should add some kind of a small garbage collection for the log parts. and write a backup when it is needed for the state machine, for the checkpointing. And these are the things that I need to do. I think when I have time, I will do that. And benchmarks, this is synchronous one. I mean, I hate benchmarks. Every single time, this is a thing that Rust comes up. There are benchmarks. And you can see a bunch of other graphs about the benchmarks of this replication algorithm in my blog. This is for single thread sequential reads. This is the sequential read operations per second in a single thread for 3-node chain. And for both of the algorithms, orange one is the ordinary one. The other one is basically the apportioned one. So these are the read throughput of it. I think that async code probably is going to make this like lift off to excellence, but I don't have time to do that. And there's no async code in the library, and I'm not going to do that because threads are the best, just realized again. So to sum up, Artillery is a state-of-the-art, I think, going to be distributed data library, and it is becoming there. Not a blockchain library or networking library, less dependencies than you can imagine. Exploits latest research techniques and other modern approaches designed for database systems and query engines and stuff like this. Mostly the data systems, to be honest, you can say. You cannot make pure distributed databases with the tooling out there in Rust. It's at planet scale because this is the algorithm that Google uses. Also, React uses, also Heroku uses, and stuff like this. So this is one of the hardcore algorithms out there, and protocols, I would say. Blazing the fast. If you're interested, read Artillery's work in progress documentation. Whenever I have time, I'm trying to write that. You can contribute to the development. There are, I didn't open issues, but as soon as I have time, I can open some issues, organize my mind and open it. You can also sponsor me, and please sustain the OSS development, open source software. And thanks for listening to me. Here we go, the Q&A parts.
Okay. Thank you so much, Mahmut. This was an amazing talk. We got a few questions over here in Zoom. The first one is your Swim-based membership available as a separate crate?
Yes, Artillery-Core. I didn't upload the version. I'm going to upload the version as soon as I have time. Just pull the GitHub, pull the Git repo, it's in there. It's separate. Everything is, even service discovery, you don't need to use, for example, the parts. Service discovery is separate. All these cluster forming protocols are separate modules, so they are not dependent to each other. There's nothing coming up as a dependency to your system. There's crossbeam, threads, nothing more, I would say. Yeah, and in a couple of places, Chaos and Bastion came. Yeah, that's all.
Cool, thanks. We have two more questions. The first one is, how are nodes in the cluster verified to be trustworthy, or is this assumed to be given by a lower level implementation that handles joining the subnet?
I didn't do that. I mean, yeah, this is one of the best questions. Yes, I didn't do that. It also, in the paper that I mentioned here, oh, sorry. In the paper that I mentioned here, it's also a problem here. So this is one of the, oops, sorry. For this also, it's a problem because DHT, and you know as the privacy related things, it is not very good thing. So Mallory, or for the security engineers out there, some Eve, like EOS dropper, can actually listen the network and join as a fake node and do some bad shenanigans. Yes, that is possible. You can check with some kind of fake entries to the zeroconf packets, signed entries. That might work, but yeah, I didn't do that.
Okay, thanks. Last question. Wondering, does your SWIP failure detectors uses UTP multicast or piggyback on membership information like mentioned on the paper? Should I repeat it?
No, I just summing up. No, I'm not using UDP multicast. I'm using the random enqueuement, like in the paper, but actually it's a good idea. Whomever wrote this, thank you. I mean, I should open an issue about that.
Okay, and let's do the last question, and then we have a little code snippet from Ryan, which we do a little hack and learn, 2 minutes max, I think. But first, the last question. How does it compare DNS service discovering using SRV and TXT records?
100% sure that DNS service discovery is going to be something like, and the production deployment is much more reliable than anything else. But data systems, most of the times are, if you know some Kubernetes or this orchestration schemes, are behaving like most of the time stateful set or daemon set. So, I mean, they are mostly affine to the node. So zeroconf can work in that environment, but yeah, it's not reliable as the normal DNS propagation, as you can imagine.
Okay. Thank you so much for your talk. This was a great talk. Ryan, do you want to start your little code exercise?
Sure. Yes. Let me share my screen real quick.
You can copy the links. So should we copy it now?
Yes,
or send
please.
It out now?
Yes, please.
I will send the link to what Ryan shows in Riot and in Zoom.
Okay. Share real quick, just for posterity's sake. Here's the very long link. Sorry for that, but hopefully those that are in the chat and stuff can just copy paste it. But if you're watching this later on, then you'll have to we'll hopefully paste it in the description of the video wherever we post it. Okay, let me stop sharing that and move on over to here. To find. All right, can everybody see my screen? Hopefully everyone sees a playground. Awesome. So I've been playing around with a bunch of unsafe code lately, and I learned an interesting thing about dropping that I thought I would talk about briefly with everybody. And this is a super contrived example. The first thing we should talk about is that if you don't need to use unsafe code, then don't use it. So hopefully you should come away with this example learning a little bit more about drop. But at the end of the day, this particular example, you would never actually do it this way in real life because there's no need to do it this way. But I couldn't come up with a better example that didn't require 10 minutes of explanation. And so what we're going to be doing today is looking at two structs, foo and bar here. And foo and bar are both structurally equivalent to each other. So foo is just composed of these two pointers, or these two numbers here, a U8 and a U8, and bar is a U16. And in memory, two U8s and a U16 are laid out exactly the same. And so what we should be able to do is effectively transmute between the two. We should look at the bytes in memory of foo and treat it as if it were bar, and it should just work, because in memory, they're effectively the exact same thing. And the fact that one is called foo and bar is, for all intents and purposes, just completely a compile time figment of our imagination. And what we're going to be doing is I implemented drop for foo and for bar here, and all they do for foo and bar is just print out dropping foo and dropping bar. So when these things are destroyed, when they're dropped, they're going to print out that they're being dropped. And the first one that we're going to be looking at real quick is this normal function. And we're just going to look at, we create a foo, we create a bar, and then we're going to see in what order they get dropped. So if we execute that real quick, then you can see down here at the bottom, we're calling normal, and it drops bar and it drops foo. And if we look at normal there, you can see they get dropped in reverse order. So first lesson for today is that depending on the order that things are instantiated in a function, they will be dropped in that reverse order. So we created foo first, and then we created bar, and then bar is dropped first and foo is dropped second. So they get dropped in reverse order. So that's awesome. We've learned that today. So now we're going to be looking at something else here. We're going to be looking at this forget function here. And what forget does is it creates a foo, and then it transmutes foo into bar. And what, if you're not familiar with stdmem transmute copy, basically what it does is you pass in a reference to something, and it just says, hey, that thing you passed to me, I'm just going to treat it as this other thing. And so it's effectively, and it basically mem copies the bytes onto the stack. And so effectively what it does is it takes all the bytes that in memory that compose that foo, and it just says, those bytes, I'm going to copy them over, and I'm going to treat it as if it were bar instead. And because foo is just 2 bytes and bar is a U16, they're the same thing. So this should work, right? But there might be a situation where we want to transmute foo into bar, but we don't want to actually drop bar. We just wish that like foo would become a bar, and we'll just forget about foo. We'll just forget that it ever existed. We don't want it to drop. And some situations where you might run into this is, let's say you're implementing your own smart pointer or something, and you want that smart pointer to move from being a smart pointer to one thing to another thing, so you need to transmute it. But if you, let's say you're doing reference counting or something like that, something that runs every time the thing drops, you're effectively saying, I'm not moving this thing, it's not being destroyed, I'm effectively stop treating it as a foo, and I'm treating it as a bar instead. And so running the destructor would be the wrong thing. In this particular example, it's not the wrong thing, because all we're doing is printing out something. But you can imagine having complex logic in your drop function that you really only want to call the drop thing once per logical value here. And so if we go at what we're going to do here is call foo, then we're going to call bar. And after we call bar, we call stdmem forget. And that says, hey, drop thing. Don't call the drop implementation on foo, just forget about it. Forget that it ever existed. We changed foo into a bar, and we just forget that foo ever existed. So when we run this, it's not actually going to print out it's not going to drop foo. And so when you could see here, calling forget, we only drop bar. Foo is just forgotten about it, never gets dropped, right? And that's really great. You might see this commented out thing here where we panic. Just keep that in mind. There's another way to implement this though. Instead of using stdmem forget, you can do the same thing using this stdmem manually drop. And what that does is it's just a simple wrapper around things. And it says, don't automatically drop this thing when it goes out of scope. Like I will tell you exactly when to drop it, or maybe I won't tell you at all. And so we wrap foo here and a manually drop, and we never drop it. And so effectively, these two things are equivalent to each other. And so if I go up here and I run manual drop instead of forget here, we should see the same thing then. We're only calling drop on bar. So we've done the same thing. We've forgotten about foo, and we've changed it into a bar, and we only drop bar. So, okay, why do I care? Like, what's the difference between these two? They can be used interchangeably, right? If I just want to not run the destructor for one thing, I can use stdmem forget, or I could use manually drop. Well, they're subtly different in different ways, and it turns out that most of the time you probably want to prefer using manually drop. And the reason for that is panics. So we're going to go back up here and run forget again. And this time we're going to panic right after we transmute to bar. And one thing that you need to know about what panics do is when something panics, it unwinds the stack. And what that means is it calls the destructor for all the local variables in your stack frame. And so when we panic here, we never reach this forget thing. We're going to run the destructor for foo and bar. And so let's run this, calling forget again. And you can see bar and foo both get destroyed. So, you know, if there was some complex logic in there that required that we only want to run the destructor for foo, we're out of luck here. Unfortunately, we're going to call the drop implementation for both foo and bar because we, you know, obviously we're not going to panic like this explicitly in our code, but there, you know, maybe you have something else that causes a panic at some point. And so it's very what we're doing here is we're not reaching this stdmem forget, and we're going to call the destructor twice. And this might have safety implications that might cause some trouble later on. So that's not good. But if we come back up here and run this manual drop instead, and this time we're using the manually drop implementation here instead, and we're gonna, just like before, panic right after calling this transmute. But the good news is that when we do that, like this, we're only going to drop bar. And why is that? Because we basically effectively said up here that we just want to forget about foo. So we've done it even before we've gone ahead to do the transmute step. And so it doesn't matter. Now, what's the downside of this way? Well, we might leak memory. So we've only called foo, the destructor for bar here. We haven't called the destructor for foo. Maybe that's what we want in this situation. But if instead we panicked right here instead, then we would potentially leak memory for foo, because we would panic right here. Foo is wrapped in this manually drop. We unwind the stack, but the destructor of the drop implementation for foo won't get called. And if that's responsible for cleaning up memory or something like that, we're out of luck, and foo will never be cleaned up. And for some things, that's not what we want. But at the end of the day, leaking memory, or, you know, consuming more memory than we need to, is unfortunate, but it's safe. Whereas running destructors twice potentially is unsafe. And so that's why you most likely want to prefer manually drop here. And I'll just end with the fact that if none of that made sense to you, or if this seems horribly confusing, that's fine. This is unsafe code, and unsafe code is supposed to be hard. So just don't use unsafe code. So that's the lesson for today. Don't use unsafe code. And thank you very much. So, by the way, I'm happy to answer questions on that. I don't think we'll take questions on the chat, but it was really great having the three speakers today. So thank you to all our speakers. Thanks again to Jan-Erik for helping out with everything. Thank you to my co-organizer Bastian for all of his hard work as well. And we really appreciate everybody showing up today. Any last words, Bastian?
Yeah, I'm happy how well this goes. I'm really looking forward to now each month for the next while to host it here. And it's also fun to have more people, not just from Berlin, but from all over the place. So thank you all for joining. And if you have any suggestions how we can make this even more fun and interesting, please feel free to reach out.
Thank you.